Namaskar, Raj Krishna this side. Let's solve this question from numerical integration. We have been given an integral 1 to 2, 1 upon x dx. We need to find this integration using trapezoidal, Simpson's 1/3 rule, and Simpson 3 by 8th rule. I hope you know that in trapezoidal rule you can divide the given interval into any number of intervals, and in Simpson's 1/3 rule you need to divide the interval into odd number of intervals, and in Simpson 3 by 8 rule you need to divide it into uh, any multiple of 3. Fine. So to get one table which applies to all, let's divide this given interval into 6 sub intervals. Okay, so we take n as 6 because 6, as you all know, will fit for trapezoidal, will fit for Simpson's 1/3 rule because it's clearly an even number and also it's a multiple of 3. Okay, so if you divide it in 6 equal intervals, so your value of h corresponding to that will be b minus a. So 2 minus 1 divided by n. So that will be 1 by 6. Fine. So let's make a table. This is your x. There comes your fx. We'll start off with 1. And the value of function at 1 is 1 only. Your function here is 1 by x. Okay, so the value of function at 1 is 1 only. Now you will have to add 1 by 6 to the previous one till you get that 2. Okay, I think that will be 6 interval. So next will be 1 plus 1 by 6. 1 plus 1 by 6 is nothing but 7 by 6. And if you see the value of a function at 7 by 6, that will be nothing but the reciprocal of that. Okay, so that will be 6 by 7. Let's find the value of 6 by 7. So it is 6 by 7 and this is clearly 0.85714. 0.85714. Next will be 7 by 6 plus 1 by 6. So that will be 8 by 6. 8 by 6 I can write as 4 by 3. And 3 by 4 value, because value of function is just the reciprocal of this. So 3 by 4 is nothing but 0.75. So this was 8 by 6. 8 by 6 plus 1 by 6 is 9 by 6. 9 by 6 is nothing but 3 by 2. So this will be 2 by 3 simply. 2 by 3 giving you 0.66. Next this was 9 by 6. I think next one will be 10 by 6. So 6 by 10 is nothing but 0.6. Next will be 11 by 6. So 6 by 11. A very simple function is there, 0.54545. And next will be 12 by 6, which is simply 2. And value of function at 2 is simply 0.5. So here becomes your table. And now let's use different 3 methods. There is one Widen rule also. We will discuss it separately, but currently we need to focus on these three rules, which are trapezoidal, Simpson 1/3, and Simpson's 3/8 rule. So moving on, so we have this. Now let's move to the trapezoidal rule. Trapezoidal rule. So with the help of trapezoidal rule, integral 1 to 2 1 upon x dx can be written as, but the general formula, that is h by 2 first value plus last value. So if I write general formula, so y naught plus yn plus 2 times the remaining values. So y1 plus y2 plus so on till yn minus 1. In some textbooks, you will see h outside, 2 being multiplied inside, so that will look a slight different. Okay. So if I use this, h was I think 1/6, yes, and half of that will be 1/12. And this y naught are the values of the function. So starting from here, yn is the last value. So this is y4, this is y5 and y6. So you'll add the first and the last value. So 1 plus 0.5 is 1.5 plus 2 times whatever is remaining. So y1 till y5. So 0.85714 plus 0.75 plus 0.66 plus 0.6 plus 0.54545. So let's jump into the calculations. So we have 2 times inside I have 0.85714 plus 0.75 plus 0.66 plus 0.6 plus 0.54545. Okay, so this is giving me 1/12, 1.5 plus 2 times of this is giving me 6.82518, and now I'll have to add them and multiply by 1/12. So 1/12, and inside bracket I have 1.5 plus 6.82518. So this is it. So I am getting it to be equal to, I don't know whether it is correct or not, it is 0.693765. What answer I have got? I think I have got the answer only for Simpson's rule. Okay, and that is also 0.69325. Okay, we'll have to wait and see what Simpson's rule has to deliver for this. So this was all about trapezoidal rule. Now moving to the Simpson's rule. So let's switch the colors. So now comes the Simpson's rule. Let's do it on the next page. So Simpson's 1/3 rule. It will take for the multiples of 2 intervals, but because we have already done interval into 6 parts, which is of course even or multiple of 2. So again, same integral 1 to 2 1 upon x dx can be written as h by 3. Now what we do here, again first plus last plus 2 times the even ones. So y2 plus y4 plus y6 plus dot 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 plus 4 times the remaining ones, or you can say the odd ones. So y1 plus y3 plus so on. Okay. I'm not writing the last value, but you may write. So h by 3. So h was 1 by 6. This will become 1 by 18. Now y naught plus y1, that was I think 1.5. 1 plus 0.5 is 1.5 plus 2 times. The odd ones. So odd ones are, we don't have to take y0 and y6 because that we have already taken. Okay. Now the odd ones are y2 and y4, which is 0.75, 0.6. 0.75 and 0.6 plus 4 times whatever is remaining now, and what is remaining here is y3, y5 and y1. So 0.85714, 0.66, 0.5454, something like that, 0.54545. So let's trust my calculation and let's break this calculation into pieces. So that 4 times of 0.85714 plus 0.66 plus 0.54545, that is giving me, this is 1 by 18, 1.5 plus something, and this 4, this is giving me 8.25036, and what is this value? 2 times of 0.75 plus 0.6. So this is nothing but 2.7. 2.7. Okay. So finally I have 1 by 18 and 1.5 plus 2.7 plus 8.25036, and this is what was the previous value, and this value I'm getting is 0.69168. Okay, if I compare it to previous value 0.6937, might happen that my value is a bit different. 696, and what is given in textbook? 0.69325. Okay, different, it's accurate up to 2 decimal places but not afterwards. So might have been there, how many decimal places they have taken? 4 decimal places. Okay, I don't think what was there, so leave that. 0.69168 is what we have got by Simpson's 1/3. Now moving on to the next one, which is your Simpson's 3 by 8 rule. So Simpson's 3 by 8 rule, and same integral 1 to 2 1 upon x dx is 3h by 8. So 3h by 8, first plus last is again there, plus 2 times y3, y6, so on, all the multiples of 3, plus 3 times whatever is remaining, okay, except for y naught, yn and all the multiples of 3, whatever is remaining. So let's y1 will be there, y2 will be there, y4 will be there, and so on. So let's use this. So 3 into h by 8. So 3 by h is 1 by 6. Okay. So 3 into h is 1 by 6, and here you have 8. So this will be 2. 1 by 16. Okay, first and last sum again, 1.5 was there, plus 2 times y3, y6. You'll not take y6 because we have already taken. Only thing which is there is y3, which is 0.66, plus 3 times 1 2 4, 1 2 4. Okay, 5 also, because that is neither multiple of 3 nor covered in y0, y6. So 1 2 4 5. So 0.85714, 0.75, plus what as 0.6 and 0.54545. This is 1 by 16. This 3 multiplied by 0.85, okay, so this is giving me 8.25. so this is 1.5 something something plus 8.25777. okay, let's calculate this also. 1.5 plus 2 times 0.66, so this is giving me 2.82. and now finally 1 by 16 and 2.82 plus 8.25777, and this is coming out to be 0.69236. okay, something like that. So this is what we have got at the end. So if I had some option to take, I think it's not visible to you right now, but yes, let's zoom it out, and yes, I think all 3 values are visible now. So trapezoidal rule, which gave us 0.693 something like that, and the Simpson's 3 by 8. You can find error in each case. Okay, exact value, you know how to find, just like you were finding in junior classes. What will be the exact value if I need to find that? So exact value will be nothing but integral 1 to 2 1 upon x dx. 1 upon x is nothing but log x from 1 to 2. So that will be upper limit. So log 2 minus log 1. Log 1 is nothing but 0. So you are getting simply log 2. And what is the value of log 2? I need to find it. So this is log base e. So ln2 value is 0.6931. So exact value, if you talk about, 0.69314. So you can see how much we have deviated from it. just by subtracting values and dividing it. If you want to find the relative error, then you can do that also. Okay, percentage error, whatever is there, so you can find that. So that's it for today. We'll see you with some more practice on this, because I like it interesting. Not as interesting as it was normal integration, but yes, we'll cover a lot of examples where we will cover all the three methods in one take. Okay, so that's it for today. Thanks and have a nice day.